did you start? Why were you interested in this topic and so on? So I think that we can just start here, and you can just present yourself, present which master program you are attending, and give a little bit about the history. And then I will have help with some questions and so on. And it's not too many people in the audience today, but feel free to raise your hand and as soon as you have something that you would like to ask or comment on. So I think that we start here. Oh yes, sorry, yeah.
So I'm Pritha. I'm from Lithuania University of Health Sciences, and I believe I'm the youngest of this discussion because I'm a fifth-year medicine student and I don't choose a field yet. But why I'm here? So basically, in our university we have students scientific association. It's like an umbrella association, and after that big name, we have more than 40 groups of students where they are interested in specific fields. For example, we have anatomy group, surgery group, and so on and so on. And I'm here because this is the second year when I'm the chairwoman of our rare diseases group. So when I was a first and second year student, I come to this big group, and I couldn't find the field where I can complete my interest. So I created these rare diseases. And why we are so unique? Because rare diseases are like now very popular in Lithuania, and also patients with rare disease are complex, unique, and also rare cases. And there you have to need a specific treatment and also a big multidisciplinary group of healthcare specialists. So we join with them and have meetings. We have joint meetings with other groups, we have meetings by ourselves, and we have discussion that called What Teachers Didn't Tell You, where we invite teachers, doctors, the healthcare specialist who shares their cases with rare disease patients, their perspectives and newest data. And also we are very unique because we have connection with rare diseases patient and their family communities. We invite them to talk, to share their story, and also we as a medicine student, we can help to provide information. Other things what we do in this group is we participate in hackathons, conferences, and also create events for rare disease patients, for students who are interested in rare diseases, and so on. And also we have opportunity last year to invite specialists from foreign countries. So we invited and have a meeting with Dr. Suya Somanhan from Ireland, from Dublin, yeah. So it was very unique and interesting thing. So that's why I want to talk, because rare diseases is very unique, and we have to talk about them, and not talk when you just face them, but also we have to talk from the students' perspectives. So here I am to share this unique project that I'm holding.
It's a fantastic initiative. Was it the students themselves, or was it you that started it up? Or?
Actually, it's my idea, but I collaborate with some doctors who are who also have interests in rare diseases, and then we give like this idea more of a look. We prepare activities that I mentioned, and then the group grows. And last year we have around 100 students who was interested in our group, and about 25 very active students. And this year we have 72 members. So it's kind of a big number for us.
It's a fantastic initiative, I think.
Yeah.
Yeah, definitely. I've never heard of anything such in Sweden, at least. Is it common? Do other students here do it similar for other disease areas, or this is exceptional?
This is for us is exceptional, but in this student scientific organization there is a lot of fields. I mentioned is more than 40. So sometimes we have joint meetings and we talk or present cases in that field. For example, in the October 24 we have a neurosurgical team, and we collaborate with that group of students, and also we invite doctors to talk more.
Fantastic. Yeah. Well, thank you very much.
Thank you.
Hi, my name is Ivanna Atava, and I'm currently studying at Latvian University and biology master's degree, and I'm currently studying in bioinformatics subgroup. My interest in biology was with me since childhood, but it was more like, as we call it in Latvia, green biology, which is more connected with zoology or botanics or that kind of stuff. And during my teenage years, I also developed my interest in medicine, and my interest in genetics, which is field in which I am now currently doing my work and studying. It appeared when I was studying in summer camp and doing small genetic project. Nothing special about just blood groups and all these A, B, and O groups and stuff, like groups mix, groups don't mix, and inheritance and that kind of stuff. Just like regular school genetics, but I was so excited about that, and I thought that it would be nice to study it. So when I chose university, I had to choose between Riga University and Latvian University, which had a biology program, and Riga University had a medicine program. But I chose Latvian University because I thought that maybe in biology there will be more like a scientific approach, because it was like a stereotype that maybe medicine, it will be more like medicine like medicine. And during my first course at bachelor's, I talked with many students from like further courses, like doctor students and master students. And they all said that there in Latvia we have also a great institute which is called Latvian Biomedicine Research and Study Center, and it is a really great place to gain some first skills and first experience in like lab work and scientific work in general. And I wrote an application and I got in genome studying group, and in this group I think most connected with precision medicine project I worked with was my first project about pediatric hematological cancers, where we were trying to find fusion genes in these blood samples from these children. And I wasn't on this project for a very long time, but we developed small publication in local Latvian journal, and as well as a poster with which I was attending to a conference, ASHG conference in Glasgow this summer. Yeah. Currently, I'm working with rare variant identification in some dominant diseases like MODY or familiar hyperholsterolemia. And I would call it also a kind of precision approach, because often MODY is mistreated as type 1 or type 2 diabetes, and only genetical testing could help to identify this. We also, apart from rare variant identification in these genes linked to these disorders, we are trying to implement also polygenic risk score to use it to distinct a MODY from type 2 diabetes or type 1 diabetes at early stages. To know if we should push some people to molecular genetic testing further or not. Yeah, that's pretty it. Thank you.
Yeah, so this links a little bit to what we heard maybe about this baby-seq this morning, that because maybe if you do the sequencing already at birth, you would never even have to think about the diagnosis when you...
Sorry?
No, I was thinking about this baby-seq project we heard about in the morning, where they sequence the babies, and then when you start to get symptoms, you can already directly classify
kind
them.
of that.
So I guess that you would promote such a study here as well.
Yeah.
So you're a medical doctor, and you're not a medical doctor. What are your plans with regards to, for example, PhD studies or working in clinical routine? Yeah, you can take one at a turn.
Yeah, actually, we don't have a residency in rare diseases or precision medicine. So my interest is in pediatrician, because every rare disease starts from the newborn. So I would like to be a pediatrician doctor, and then my interests are very big. So I will broaden my horizons in rare diseases. Yeah,
Thanks.
Yeah, my interest is more in bioinformatics, because while I was trying to do these studies and implement my coursework at university, I also was introduced to genome data analysis, and I thought that it is quite interesting. And I'm not a programmer, but it still was something more interesting maybe for me than just simple work in lab. And because of that, I think my future plans for doctors and postdoc and also master studies is bioinformatics to teach programming more and to be really great professional, not only in biology knowing, but also in some scripts and programs, because even now we have a kind of great problem with bioinformaticians. I don't think that this is actual not only for our country, but I think that in many countries is the same problem, that there's a lack of specialists, and also for people who know both biology and programming. And I think that it would be really great to make more that people and to these people to teach new people, because we also, because of lack of specialists, we have a lack of new students, because nobody can learn something if there is nobody to teach you.
No, absolutely. No, we're starting up now a PhD school in data-driven life science with focus on precision medicine and diagnostics as well. But we realized that it might be hard to find the students who should apply for these positions, actually. So I think that's a good stuff. Okay, let's move on. Thank you very much.
Okay, so hi, my name is Dzvinka Yarish. I am a second-year master's student at the University of Tartu. And I guess my story is a bit of a mirror to Ivanna's story, because I came from computer science. I did my bachelor's in computer science. Then I worked in IT for a bit, and at that point I realized that I want to do some interdisciplinary work, and that's why I went for a master's in Tartu, because they have a really strong group in bioinformatics. So I'm doing a computer science master, but I'm also working in a computational genomics lab, where I try to use machine learning to predict the effect of variances on gene expression. Yes, so that's about it.
So do you feel like you miss a bit of the biological background, or do you think it's okay with the computer science background in this field?
It's not for me to judge, I guess, because yeah, I at the beginning I was feeling very lost, and all of this new terminology and a lot of abbreviations. I don't know why you people love abbreviations so much, but like that was so overwhelming. But then I started to kind of, I don't know, learn and adapt, and we had a bioinformatics course where we kind of get a broad overview of genetics and all of the like biological mechanisms. But I guess for me it was always about learning by myself. So I just when I see the area in which I lack knowledge, I try to read about it somewhere.
And I think that this possibility to network with other people as well and see what people are doing outside of the universities is really good as well.
Yes, of course.
And what are your future plans then after?
Oh, well, ideally, I would like to combine industry and academia, so get an industrial PhD. That's like the big goal. I'm still looking for a company that would agree to those terms, because, well, that's a rare find. So if you have any pointers, that would be much appreciated.
Yeah, you should definitely keep your eyes open on this data-driven life science program that we have in Sweden. I would like to recruit all students to Sweden, of course. And but look at that webpage, because there are going to be announcements for PhD students coming up, both in combination with industry and with pure academic.
That's great. Okay, thank you.
But probably not until next year or mid next year, maybe.
Okay, my name is Josephine Heinold. I study in Sweden, Uppsala University. My master program is molecular medicine. Why I applied to be here is, it's a bit maybe a longer story. My bachelor is pharmaceutical biotechnology, which is really industrial, like it's also sponsored by big companies in Germany, where I did my bachelor. And when it came to my bachelor thesis, I thought like, oh, maybe academia would be a nice other approach to it. So I went to Sweden, to Uppsala, and did my bachelor thesis there. And it was in the midst of COVID. And the masters were mostly online, only the lab was restricted, or only the lab was in person, the rest was all online. So I chose to take a gap year and work there as a research assistant in the neuro-oncology department with glioblastoma, and that's such a heterogeneous brain tumor, not only within the patient but also between patients. There's not really a cure. So that was really what drew me into staying in academia, because it was so much fun trying different methods. So I applied for a master in molecular medicine, and while that doesn't have that much to do with precision medicine, I think it might be a really interesting approach for this disease also, because it's so heterogeneous. So treating one patient with one medication might help not the next one. So that's why I think it's really interesting.
Yeah, and you're on the second year now, so you're
Yes.
starting on the master degree project.
Yeah, in a month.
In a month. And do you plan for a PhD as well? You sound like you're
Yeah.
very interested in academia.
Yeah, I would like to stay in neuroscience. I don't know if glioblastoma is the topic yet, but I really enjoyed academia so far, so I'm not really looking for industry positions after my master.
Hi, my name is Pritha. I have done my master's in precision medicine in the University of Manchester. It's the first year that they provided precision medicine as a master's course, which should say enough about how the importance of precision medicine is growing in today's world. And so the first time I came across the concept of precision medicine was during my bachelor's. I did my bachelor's in biochemistry at University of Manchester. And over there, I had a course, a unit for a role of diagnostics in medicine. And over there, they taught us about precision medicine and how right now we have a one-size-fits-all concept for treatment. And precision medicine is a more tailored therapy, more patient-based therapy. And that really stuck to me because the one-size-fits-all concept, let's be honest, it doesn't even work with clothes. So obviously, I thought it was interesting, and I thought that it would revolutionize healthcare in the future, and that's why I took the course, and I don't regret it at all because I saw how different omic technologies, genomics, metabolomics, proteomics, all of them can help create a profile that can have a very tailored therapy for a particular patient. But of course, there are more problems associated to it, to the information that comes from all these technologies. But I'm sure with the development in technologies and our understanding for molecular biology, we can overcome these problems also. But yeah, that's what I did. And I also had a 6-month project as a part of my master's degree where I looked at the role of PARP14, an enzyme, in the role of it in adaptive immune resistance against PD-1, PD-L1 immune checkpoint blockade therapy in cancer cells. So yeah, I just completed it a few months ago, and I'm waiting to graduate.
Okay. So, and what are your plans after the graduation then?
Well, right now I kind of started a second master's at University of Antwerp in biomedical sciences of infectious and tropical diseases. But after this, I want to do a PhD. Yeah.
And I think that maybe Manchester and Copenhagen were the first universities to start this precision medicine masters, if I have
Yes, I think so.
it correctly.
Yeah.
And we started in Uppsala this year, and I know that there are some universities that are starting up or planning for starting up. So it's quite a new idea. I think that in some way these masters are a little bit similar to the existing programs, but what we would like to incorporate is, of course, the bigger picture a little bit. How are you going to do it to help the patients, which is sometimes it's a bit more realistic picture that we can give in healthcare compared to what we can give in academia, where we teach students about genomics and omics technologies, because there are so many fantastic possibilities what we could do in the lab, but which might not be really feasible in the clinic in the end. And I think that is what you hear a lot about here as well. But what do you think is the challenge? What was the reason to go to this conference then? Because you're also, I can understand that there's different topics, you're all interested in research, but is it really like that you're burning for like helping patients, or is it like the big scientific question, or what is the main driver here to interest in the conference and in precision medicine?
Did you ask why we are here?
Yeah, being here and also the interest in precision medicine. Is it mainly like that it's a really interesting research field that is exciting, moving quick forward, you hear a lot about it, or is it really to help the individual patients? What is the like main driver for you to be interested in precision medicine?
I think for me, it's the patient-based care part of it. And also there was a very interesting talk about preventative genetics in the morning, which I thought was very interesting, and how they found certain diseases in people who were apparently well. And I think that's very important, and that can help us tackle a lot of diseases from early on. And yeah, I think that's one of the most interesting things I thought about the conference and precision medicine.
I always enjoy going to conferences because, first of all, you can talk to other scientists, but also this one is really based on patients. And where I worked before, where I studied, it's more really academia, like research, so still far away from the patients. So I always think it's super interesting to see those healthcare workers or doctors, and then you can see what is applied right now, because even though you read papers, you don't really get to know everything. So I think it's a really great opportunity to see it from like a different perspective, because
and it also differs a little bit between the countries.
Exactly.
So
yeah, like this morning when they first talked about Sweden and then about Ireland, like there were like huge differences also with the general healthcare system. So I think that's always interesting to see.
I think for me, it's it's my first conference in like a biology and medicine related fields. So for me, I guess it's like a test of how much will I be able to understand and just the test of to see how well I fit into this community and maybe get some new connections and so on. But actually, if we look at the bigger picture here, I think that while applications of machine learning to image analysis or text analysis, they're all very interesting, but there we are just teaching the machines to do what humans already know how to do. So basically just to copy our skills. But when we apply those ML models to, for example, for genome sequencing data, then we actually have the potential to uncover some new knowledge and some new patterns in the data and kind of drive this scientific progress. And of course, with the progress and more knowledge, somewhere comes and the direct impact on the patients.
Yeah, that was a really good point, because we always highlight imaging as the big AI field, but you're absolutely right. Predicting causality or causal effects by different genetic variants is something that we would never be able to do without having some good machine learning AI behind it.
Yes, exactly. Those new fancy giant ML models, they all already know how to speak a human language, but they still have to learn how to speak the language of nature, the DNA. So, yeah.
It will be easier to like operate with two microphones, not only one.
Yes,
About question why we are doing it for patients or for some else, for ourselves, or I think it's everything, like both patients, because it's really important to improve life quality of those who can have less because of some genetic malformations or something like that. And I personally would like to receive help if it would be possible, and that's why I'm probably doing research, because I want people in future to have a possibility to have this help to be properly treated, or at least for people to know what is wrong with them. Not like I'm ill, but I even don't know what is going on with me. Also, I think that many of us are doing the research also for ourselves, because it's interesting. It is a new knowledge which in the field which you really like, and I think you can't really survive in science, like in general science, without like some enthusiasm and real like willingness to gain new information, because there's a lots of overworks and stuff which isn't always going well and as predicted as you would like it. For example, some experiments fail, or data fail, or something like that, which can be really frustrating. And without this enthusiasm and really great interest in doing that because you really want to do it for yourself, to prove something to yourself, or to just gain this something new in this world, this is which is driving us further.
Yeah,
I think.
I totally agree on that point, and I feel the same as a preclinical researcher. I don't often meet patients, so it's mainly the curiosity and the the scientific part that drives me to work late nights and Saturday mornings, for example. But I think that maybe we have a different point from a medical student.
I have mentioned that my interest is rare diseases, and we are counting about 10,000 of rare diseases, and 80% of them are genetic. So there is no one treatment for one patient. For all patients, you have to gather the good amount of people to cure them, to treat them, and for that reason I'm in this conference, because precision medicine is one of the necessity for rare disease patients, and I want to collect all the information and bring to Lithuania, and maybe in the future we also have like a residency or a program to exactly about precision medicine and what this program can offer for us and for the patients. That's why.
Hopefully, I think so as well. So is there anything that you feel like you definitely highlight the like gap that you miss at the university, but is there something that you miss? Is there something that you would like to learn about that you feel like the university cannot provide for you today?
Yeah, I can start. Maybe somebody will talk also. I would really like to, as I'm now studying bioinformatics, I would really like to gain more experience in just simple programming, not only with biological data, but just to understand programming languages, because it is something which wasn't on my program and which is now really a great problem for me now, as well as, for example, statistics, which I also didn't have at university, and I almost forgotten all the stuff they teach us in schools. But for bioinformatics and in general data analysis, it's really important to understand the statistics. And when you don't have it at university at bachelor's, and then when you're making some experiments or some things later, you just feel that you would like to understand, but you don't understand because you don't remember all these things. And yeah, it would be really nice to gain this thing by ourselves, because we won't have this probably at university because it's not like part of our program.
No, and that's a bit unfortunate, because I think this is also when we get like master degree students or PhD students who wants to have projects. It's always something that we see that they are like, either they are computer scientists because they can do all of it, or they are like from the biological or biomedical side and they have very little in these topics, and that is very unfortunate, I think, as well.
Yeah, so I think for me, I would really like to spend at least one day in the lab, just watching the biologists do their work, so that I can better understand the source of the data and the errors that can be found in it because of the work processes that are in the lab. So this is just my.
For me, it's probably critical thinking. We have journal clubs in our master where we all read the paper, one person presents it, and then we talk about it, but we're not really forced to have like a critical discussion, because when you look at something critical, you don't mean it in a mean way. Because you only learn from mistakes either from your own or from other people's mistakes. So I think that's like more critical thinking, because I think that's important.
Yeah, and I think especially when it comes to this border between preclinical research and precision medicine, it's really important to be critical, because it's so common, me and others, we just write as a conclusion, this will be useful for precision medicine in the future, especially in grant applications. But being critical against this and really question how are you going to take it all the way, it's a really, really important question, I think, here.
For me, I am completely opposite to Dzvinka, and I barely have any knowledge of the computer and the data analysis bit, so I've mostly worked in the lab in the wet lab. And so yeah, I think I would like to learn some programming language and the data analysis part of it also, because I think that really helps, that data analysis bit is one of the most important things, and that really helps in translating the laboratory data into the clinic. So yeah.
Yeah, so there were many good points coming up here. So we're actually just 1 minute left now. So I think that if there's not any urgent questions from the audience here, then I would like to take a photo of you if it's okay before we end this session. Is it okay with everyone? Or maybe you have some photos that you can share. I can take one myself to be sure. Yeah, fantastic. Fantastic. And I'm a little sad that we didn't have a larger audience today, but you did a fantastic job. And for me, this was really interesting to hear about your stories. And it will help me when we are continue to develop our master program as well. So thank you very much for this session. And thank the organizers as well.